Rutherford determined the place of the protons inside the nucleus, which is a small area of the atom. And in the nucleus we have neutrons. So by the model of Thomson, Goldstein, and Rutherford, we can say that the atom is composed of a nucleus containing protons and neutrons, and around we have electrons in motion. Now we will ask some questions to pass to another theory. The electron is charged negatively, and the nucleus containing protons charged positively. So the electrons around the nucleus will be attracted by the protons, and in this case the electron will fall down to the nucleus, so the atom will collapse, so the atom does not exist. This is the first inconvenience about the previous atomic models. And also, you know, in the modern physics that any particle in motion around a center, and this particle is attracted by the center, so this particle during its motion will lose energy. The potential energy of the electron around the nucleus is equal to the charge of the electron times the charge of the proton divided by r, which is the distance between the nucleus and this electron. So the potential energy is equal minus E squared divided by r. And r is the distance between the proton, between the nucleus and the electron in motion. And by the modern physics, we said that this electron will lose energy. So minus E squared divided by r will decrease. And in this case, r will decrease. If r increase, E squared divided by r decrease. And we have minus. So if r increase, the potential energy increase. R decrease, that means we lose energy. And in this case, the electron will fall down to the nucleus. So again, the atom will collapse. So the atom does not exist. So till now, we asked two questions. Why the electron is not attracted by the proton? And the second question, why the electron did not lose energy during its motion around the nucleus? This is inconvenience of the previous atomic model. So we have to find answers for these two inconveniences. To another model, which is the Bohr theory. According to Bohr, the energy of hydrogen atom is quantized. That means the energy of the electron could not take any value. And this is also defined by Planck. Quantized means that the atom can only have very specific amount of energy or allowed values of energy. Bohr calculated the energy of the electron in a level, and he found that En equal minus 2.18 times 10 minus 18 divided by n square. And n is integer number 1, 2, 3, 4. Okay? What is the meaning of this formula? If n equal 1, that means if the electron is found at level 1, so E1 equal minus 2.18 10 minus 18 joule. If the electron is found at level 2, so E2 equal the energy of level 2 equal minus 2.18 10 minus 18 divided by 2 square. If the electron is found on level 3, E of level 3 equal minus 2.18 times 10 minus 18 divided by 3 square. So the allowed value are minus 2.18 10 minus 18 or minus 2.18 10 minus 18 divided by 2 square or minus 2.18 10 minus 18 divided by 3 square. So the values of the energy levels are quantized, cannot take any value, can take only specific values. Bohr in his theory supposed that the electron is found on orbits, and these orbits are of known distance from the nucleus. That means the electron did not fall down to the nucleus because the orbit protects this electron. The electron is found on this orbit. Therefore, the energy of the electron is related to the distance of the orbit. In other words, suppose I have hydrogen atom and I have one electron. What is the place of the electron? I will suppose that the electron is found on level 1. Bohr supposed that the electron is found on orbit, which is a place. And this orbit has a known energy and a known distance from the nucleus. Calculate what is the distance of the orbit from the nucleus and what is the energy of the orbit. So to Bohr answer the two previous inconveniences. The first inconvenience, why the atom is not attracted by the proton, and the second inconvenience, why the electron did not fall down to the nucleus by losing energy. The answer of the Bohr, the electron is protected by its presence on orbit, and the orbit has a known energy and has a known distance from the nucleus. So the electron is in motion around the nucleus, and the electron can be found on orbits. For example, n equal 1, this is orbit 1 of known energy E1, or the electron can be found on orbit 2 of known energy E2 and known distance from the nucleus, or orbit 3 or orbit 4. And these orbits are the protection of the electrons from falling down to the nucleus. What is the meaning of the energy is quantized? If we look to these orbits, between orbit 1 and orbit 2, we have a space. So the electron cannot be found between level 1 and level 2. Or the electron is found on level 1 on orbit 1, or the electron on level 2, or the electron on level 3. So the energy level are quantized. As long as electron remain in a shell, it never gains or lose energy. The electron can pass from one level to another level, for example, from level 1 to level 2, or the electron can return from 2 to 1. So the electron can jump from one orbit to another orbit, but when the electron is on known orbit, it does not gain or lose energy. The gain or loss of energy takes place within orbits only due to jumping of electrons from one energy level to another energy level. And as I said, if the electron is on orbit 1 and we want that this electron pass to level 2, we have to give to the atom exactly the difference of energies between level 2 and level 1. On orbit, the angular momentum of electron is directly proportional to nh over 2 pi. For example, suppose you have electron on level 2. The mass of the electron is known, is constant, equal 9.11 10 minus 31 kilogram. V is the speed of the electron on level 2. R is the distance of the electron at level 2 to the nucleus. N is the number of the level. H is constant. So the angular Bohr proved that the angular momentum of the electron is directly proportional to nh over 2 pi. If the electron is found on level 1, I will write the formula by this way. M V1 R1 equal N1, which is equal 1, H divided by 2 pi. If the electron is found on level 2, M is constant. M V2 times R2 equal 2 times H divided by 2 pi. So my question now, why the speed of the electron change from one level to another level, and why R change from one level to another level? The answer for R is very easy, because R is the distance between the electron and the nucleus. If the electron is on level 1, its distance from the nucleus is R1. If the electron is at level 2, its distance from the nucleus is R2. Now, why the speed of the electron change from level 1 to 2 to 3? Because at level 1, the electron is highly attracted. The electron is close to the nucleus. So its motion is less free than this electron if found at level 2, because this electron is less attracted. So the speed and the position of the electron depends on the number of the orbit according to Bohr theory. N is the number of the orbit and H is a Planck constant. R is the radius of the orbit, or is the distance between the electron and the nucleus. So now, how to calculate the speed of the electron on orbit, how to calculate the distance of the electron from the nucleus, and how to calculate the energy of the electron on orbit. We have three terms, E, V, and R. In this year, the concept or the proof of the formula is not requested. You have to take only the formulas, but I will explain some points. Suppose the electron is around the nucleus. We have two forces applied to this electron, which is the attraction force Fc and the centrifuge force F centrifuge. Since the electron is at equilibrium, because the electron did not fall down to the nucleus, so F centrifuge is equal F attraction. Fc equal F centrifuge. As I said, the proof of this formula is not requested this year, so you will take only how to apply this formula. We will find that the radius of the orbit is equal R equal a constant A times n square divided by Z. Consider our example, which is the hydrogen atom. In hydrogen, Z equal 1 and A0 is constant equal 0.53. So R in angstrom, the distance of the electron from the nucleus is equal to a constant A0 known times the number of the orbit square divided by Z, which is the atomic number of the element. Or in picometers, since A equals 0.529 angstrom, so equal 53 picometer. The radius of the orbit or the distance of the electron from the nucleus in picometer is equal 53 n square. N is the number of orbit divided by Z, which is the atomic number of element. Our question is, our case is the hydrogen. In hydrogen, Z equal 1, so the radius in angstrom equals 0.529 n square. Suppose that the electron is in orbit 1, so orbit 1 is distant from the nucleus 0.529 angstrom. Suppose the electron is level 2, its distance from the nucleus is 2.11 angstrom. Suppose the electron is found on level 3, its distance from nucleus is 4.75 angstrom. And for R4, R5, what is the energy of the electron in orbit? The proof is not requested. Okay, you have to know only the formula. The energy of the electron on orbit equal minus 13.6 times Z of this element square divided by the number of orbit square, and the value is in electron volt. So for hydrogen, Z equal 1. So the total energy of electron on orbit is equal to minus 13.6 divided by n square. In hydrogen, the electron found on level 1 has energy minus 13.6 electron volt. The electron found on orbit 2 has energy minus 13.6 divided by 2 square. And the energy can be given in electron volt, or you can apply the formula in joules. The total energy is equal minus 2.18, 10 minus 18 divided by n square, Z square in joule, or minus 13.6 Z square divided by n square in electron volt.